Good day everyone, my name is Graphics. Today we'll be looking at frame structure, where we'll be discussing more about a frame. We know a frame is also called a truss, and a truss is a structure made up of several members connected to each other, right? So a truss is used when heavy loads are to be resisted or the span is very high. What means span? It means the distance between two supports, right? For instance, now if I have a beam this way and I have a support here like this, right? So when distance from here to here is called what? A span. As when I mean a span, right? So we use a truss when the distance between the supports is very large. We also use truss in roof too, in industrial building, in workshop. Why? So and they are supported by what? By walls. If you go to industries and in industries you see trusses on the wall, or go to a building that is being constructed and check the roof. It's always resting on the wall. Are we good? Now, we're moving forward. We have different types of frame. The first frame that we have is called a perfect frame, is one, and the second one is an imperfect frame. Now let's talk about a perfect frame. When we talk about a perfect frame here, you see that if the number of the member in a frame is just sufficient to keep it in equilibrium under any external force acting at its joint, right? Now what I mean by members, now let's take this for example. If I have a triangle this way, right, and this is A, B and C. The member here, AC, is a member, A to B is another member, C to B or B to C is another member. So we have three members in this frame structure here. Is that okay now? We should also know that another name for perfect frame is called what? Efficient frame, right? And for a frame to be perfect, it must what? It must satisfy the equation n is equals to what? 2j minus 3. For a frame to be what? To be perfect. Where n is given as what? The number. The number of what? The number of members. J is given as what? The number of joints. So how many joints do we have here? This is a joint, this is a joint, and this is a joint, right? So let's see if this triangle here is a perfect frame or not. Now n is what? Is 3, because how many number of members do we have? We have AC, AB and BC. So our n is equals to what? 3. How many joints do we have? We also have 3 joints. 1, 2, 3. 3 joints. So our J is given as what? 3. So if we input it in this equation here, 1, so we'll be having that my n is equals to 2j minus 3. So what is the n? N is 3. 2 brackets what? J is what? 3 minus 3. So my 3 will be equals to what? 2 times 3 is 6 minus 3. So 3 is equals to what? 3. Now we see that our n is equal to what? 2j minus 3. So we say this frame here is perfect. Are we good? So we say this frame here is what? A perfect frame. Now also we'll be talking about an imperfect frame now. So an imperfect frame is a frame that doesn't satisfy this equation n is equals to what? 2j minus 3. So any frame that doesn't satisfy this equation is said to be what? Imperfect, right? And there are two types of imperfect frame. The first imperfect frame that we have is called what? Deficient frame. Deficient frame. And the other one is called what? Redundant frame. Redundant frame. Are we good? So when we talk about deficient frame is one in which a member is less than, that means n is less than what? 2j minus 3. That is deficient frame. While for redundant frame, n is greater than what? 2j minus 3. Are we good? So we should know one thing, that in deficient frame, the number of the is less than what? 2j minus 3. So let's take for example now, I have a square as my structure, right, or a rectangle, and this is A, B, C, and D, right? Now in this case here now, my number n, which is the number of the member, we know that AB is a member, BC is another member, CD is another member, AD is another member. So we have 1, 2, 3, 4. So we have 4 members here. Are we good now? Now we're moving forward. We have 4 members there. Then J is the joint. How many joints do we have? This is 1, 2, 3, 4. We also have what? 4 joints. So if you place this into this equation here, let's see what will happen. Let's put that. So from here, we know that n less than 2j minus 3, right? So what is our n? Our n is 4. Is it less than our 2j is what? 2 is, our j is also 4 minus 3. So from here, 4 less than 8 minus 3. So 8 minus 3 is 4 less than what? 5. So we see that the number of the member is less than, that is n is less than what? 2j minus 3. So you see this frame is what? Is deficient, because it satisfies this equation. Are we good? Now let's take this example again. Now look at this example here. We have this frame. We want to see if it's perfect or imperfect. Right? Now, we know that for a frame to be perfect, it must satisfy the equation n equals to what? 2j minus 3. Are we good? So let's see. N, it says the number of the member. Now let's check. We have AB is a member, that is 1. BC is another member. CD is another member. DE is another member. EF is another member. FA is another member, or AF is another member, right? Now also BF is another member. BF is another member, right? Also CE is another member. So we have 1, 2, 3, 4, 5, 6, 7, 8. We have 8 members in this structure here. Now let's see how many joints do we have here. A is a joint 1, that is 1. B is a joint, that is 2. F is a joint, that is 3, 4, 5, and 6, and we have what? 6 joints. Are we good? So if it's that way, we will put them into this equation here. So what is our n? Our n is 8 equals to 2 into bracket. What is j? J is 6. Then minus 3, right? So we're having 8 is equals to 2 times 6 is what? Is 12 minus 3. So 8 will be equals to what? 12 minus 3, that will be what? 9. Now what do you notice? N is less than what? 9. n is less than 9. So when it's less than 9, we say it is what? It is when n is less than, we say to be what? Deficient. Are we good? When n is less than, we say to be what? Deficient. So you should know that very well. Now let's take this example again. I have a frame this way, coming this direction and this direction. So let's say this is A, B, C, D, right? Let's see how many frame structures we have here. AB is this member, BC is another member, CD is another member, AD is another member, right? Then AC is another member, then BD is another member. So we have 1, 2, 3, 4, 5, 6. So our n is equal to what? 6. So how many joints do we have here? We have 1, 2, 3, 4. So our joint J is equal to what? 4. And we say that for you to know if it is a perfect frame, we're using this formula that says that n is equal to what? 2j minus 3. So let's put n here now. N is what? 6. 2 into bracket j is what? 4 minus 3. So 6 will give me what? 8 minus 3, right? 6 will now give me what? Equals to 5. Now what do you notice? The n is greater than what? This 5. So it means that 2, the n is what? Is greater than what? 2j minus 3. So when it's greater than, it's called what? If you look at what I've said earlier, when it is greater than, it is called a redundant force. When n is greater than this, it's called a redundant force. When n is less than this, it's called a deficient force. But when n is equal to this, it's said to be what? A perfect frame. So both redundant and what? Deficient, they are all what? Imperfect frame. Are we good now? So you should know that from now that this is the equation that determines if a frame is perfect, imperfect, which can be redundant or deficient. Are we good now? So when the n is equals to this, is perfect. When the n is less than this, it is deficient. When the n is greater than this, is called what? Redundant. So in our next video, we'll be talking more of reaction at support. Thank you very much for watching.